So, the last time we talked to Chris Dunn, we discussed the Giza power plant theory and his book, The Giza Power Plant. Today, we're going to be discussing lost technologies of ancient Egypt, advanced engineering in the Temple of the Pharaohs, and he's going to give us an update on his recent trip there. So, let's not delay our guest anymore. Welcome to Capricorn Radio, Chris.
Thank you, James.
Sure. Now, man, what a beautiful book that is. Like, I'm an engineer, Chris. I appreciate this stuff. But I guess, the thing for me is I don't see, with the Giza power plant too as well, I can't see Egyptology in the same light again. It's things change when you read your books, Chris. This is not a paradigm shift. This is a paradigm buster, this stuff.
Well, thank you. Egypt certainly changed for me after I paid it a visit. Even before, when I was reading about all the information that is not generally available to people when they're in school. My mind was changed then, but actually visiting Egypt opens your mind quite a bit, particularly for an engineer.
Sure. And I guess that's the thing. A lot of engineers flock there, and the engineers have a different eye, Chris, and I guess that's what we talked about last time, and this is the difference that you bring to the table. Obviously, you'd work in a different engineering. You work in the precision engineering field, and you understand precision. You've got the eye for it. You understand tool making and tooling. And this is what the Egyptians did. They engineered very difficult, complex designs. And I guess this was like a play field for you when you went there and you turned it into research then. Would that be fair to say?
Oh, that is a very, very good description of it. And, just the kind of bridge the gap between now and when I started my career and how precision plays into it. Mm-hmm. I began an apprenticeship at a very young age in Manchester.
Sure.
Down the road from David, just a stone throw away, right, David?
Yes, absolutely, yeah.
And of course, Mancunians and Liverpudlians always hold a tremendous respect for each other.
I like your humor, Chris.
And talking to you guys, my accent is probably going to drift back into my Mancunian accent. I don't know.
But I'm always intrigued by your accent, Chris, because it sort of drifts between the two all the time.
Yeah, man without a country, I think. No, I've been actually honored and humbled to be able to explore and discover and bring this information to light. And it's very gratifying to meet fellow engineers all over the world that appreciate that and are adding their own voice to it. So it's incredibly satisfying to me.
I guess in a way it kind of reminds me of when Shock has the geologists on his side, because geology follows the science, and Egyptology doesn't have qualifications or any right to discuss really in-depth scientific geology or engineering. They're not qualified engineers. They're not qualified geologists. And these are the two battles that they're fighting, I guess, Chris, is what I'm trying to say. But Shock will have his followers of geology, and like you, Chris, anybody that's into science and engineering can clearly see the problem that these Egyptologists are facing with copper chisels, highly machined granites and diorites, extremely hard stones. And I think what you've brought to the table is you've brought this methodology for people that have any even technological know-how to go, well, we don't have the engineering eye, but Chris does, and he's able to present it in his books and in this manner and show us the problems, show us that there must be tooling, there must be machines, something had to guide these chisels or whatever they carved this stuff with, like.
Well, yes, obviously the facts are there, they're on the ground, and all you have to do is go and look at it and measure it. Mm-hmm. And, of course, we can discuss about what kind of tools were used.
Mm-hmm.
But in those discussions among engineers, you never hear any mention of copper chisels or stone pounders or anything like that. So, they kind of move beyond that notion. But having said that, I would also say that archaeology is a respected field.
Sure.
Egyptology, the offshoot of it, is a respected field.
Sure.
And I think along the way, they try to engage in certain experts. But as you know yourself, when you talk about culture within a particular society or civilization, no one person has all the answers in terms of explaining what that culture was about, what they were doing. And in the area of manufacturing, that is the cultural environment of manufacturing that I have been in, both in the UK and in the States. We think alike. So, along the same lines, we may describe certain objects, have different names for them,
Mm-hmm.
but still, in terms of the physical requirements and demands that materials present to us in shaping them or turning them, adding value to them, making them useful, they're pretty much universal. And because we're faced with the same constraints, the same problems, same difficulties.
Sure.
And so if you don't have somebody in the room that has, that kind of background and understanding, then I think that you're probably going to miss a lot, and a lot has been missed.
Mm-hmm. Well, okay, so we're going to talk advanced machining in ancient Egypt, Chris.
Yeah.
To do that, we're going to talk about certain artifacts, certain places in Egypt. I suppose let's head to Luxor first. The art and the temples there is probably the best. I mean, I know you in your first area of research, you researched the pyramids, but you followed on your research and the metrology, the science of precision and measurement, and you've ended up going to Luxor on several occasions and looking at the art, the temples, and it's very appealing. It's this is like, it's jaw dropping looking at this stuff. And just for the listeners, some of this stuff's done in pink granite where you can see your reflection in it. Like, that's how highly polished, and there's lovely curves. And as you say, I liked when you wrote in the book about the engineer running their hand, because when you finish a product in the manufacturing industry, it's what you do as a human. You put your hand on your, like a finished car or whatever, or a paint job, or you would run your hand over it. And right. I was laughing when I was reading your book, because I can just picture you in Egypt running your hands over these ancient statues and stuff, like, and just to
that's the first thing that you do. I mean, before you open your toolbox and pull out your instruments, it's that tactile connection with the piece. And like you said, if you are in manufacturing, you're creating a die for a car body or something like that.
Mm-hmm.
You're checking form, you're checking finish,
mm-hmm.
and a lot of that has to do with the hand and the eye.
Sure. Yeah, so let's talk about these head jets and the arcs and the symmetry and their true radius. And this is beautiful, and I love what you do, Chris. I really do, because it's founded in mathematics. It's founded in this new. I know what you do with the symmetry and the overlaying of transparencies and stuff. So perhaps talk about the head jet and the arcs first.
Yeah. Well, those are the white crowns of Upper Egypt. And they're conical shaped.
Mm-hmm.
And I first kind of connected with them the first time I went into the Luxor temple. And we were with a tour group. It was 2004, and it was in the evening, and that's when they recommend that you visit that temple, because it is quite inspiring with the lighting, and it has it has quite an allure to it.
Mm-hmm.
And the Egyptologists were discussing the reliefs and the hieroglyphs on the walls and telling the story. And I noticed that these granite headsets just laying in front of these statues. The statues were broken,
Sure.
some of them, but these objects seemed to gleam in the light. And so I walked up to one of them and I just ran my hands over it, and I was absolutely amazed at the finish and the apparent perfection and smoothness of the object. So that impressed me, and it stayed with me for quite a long time. But I didn't use the digital photography at that time. That was in 2004. I think I had a film camera with me, but I was a speaker on the tour, and so I wasn't there to, take photographs. Well, I could have taken photographs, but it just wasn't what I was there for. I was there to be with the guests.
Sure.
So whatever guests were interested, I kind of pointed these out and expressed, a certain amount of interest in them and excitement that we find in a temple the same kind of surface finish and apparent precision that I had noted in around Giza, on the Giza Plateau and in the Valley Temple.
Mm-hmm.
And so, but I filed that away. But then it was a couple of years later that I started to get the urge to do more research, and I was interested in learning more about the work of Schwaller de Lubicz, and I'm also fascinated with the work of John Anthony West.
Sure.
And so I signed on for one of his tours in 2006. It was February 2006. So I signed on as a just as a guest. Mm-hmm. And but I had the intention of going into the Luxor temple as well as receiving his information, being able to do more work with those headdresses. Mm-hmm. And I bought I think it was an 8 megapixel camera, digital camera, because in the few years prior to that, one of the metrology instruments that was becoming more popular in manufacturing and being used more and more was the optical acquisition of data. So you photograph a part with a digital camera, mm-hmm. and then you import it into a graphics program or a CAD program, mm-hmm. or any special purpose program to measure it, and with the resolution of the camera, and also the resolution of the software itself. You can measure something to within 1,000th of an inch or even less.
Sophisticated then, Chris.
Very sophisticated, yes. And these instruments are being applied more and more. And today they're getting extremely sophisticated with 3-dimensional systems that will photograph something in 3D and then model it in the computer in 3D. Mm-hmm. Revealing very complex surfaces and then comparing the surface that has been created with the actual model that is held in the computer. So that technology was growing, and so I said, well, as far as actually measuring one of these things, the least I could do is take digital photographs and then bring them into my computer program, and to the best of my ability and the software that I had, just see if there is anything there that I cannot see just with the naked eye. So one of the one object I photographed was the head jet, and the conical crown.
Mm-hmm.
And my camera was handheld. I also photographed the Ramses head, but not with the intention of taking an accurate photograph that would be able to reveal what I ultimately revealed after several visits after that.
Mm.
But and I took the photographs, and then, the tour moved on. We went to other places, but I had my PC with me, and I was importing the photographs and looking at them in my room. And I got very excited because the information that was revealed was a lot more than I expected. And for instance, the photograph of the head jet, the white crown, that revealed that both sides were identical. The radius on both sides of the cone were identical, and I did that by bringing the photograph into my computer software, describing circles, and then matching the circles against each side, and then I even made a copy of the photograph, turned it into a transparency, flipped it horizontally, and then matched both sides that way. So, just even without asking the question, well, just how precise is it? I mean, down to a thousandth of an inch, or even half a thousandth of an inch. What quantitative measures could I gain from that? And I had to leave that question because I wasn't able to determine what the exact dimensions were. But just visually looking at it, and then remembering the first time and also the last time that I ran my hands over it, it seemed that what was happening was the Egyptians were machining these pieces to certain geometry that was very precise, symmetrical, and also that they were probably encoding information in them. What that information was at the time, I don't know. Mm. But anyway, that was incredibly exciting.
Sure.
And then the Ramses head in the forecourt outside the Luxor temple, and I looked at that in my computer, and that was it's like some things actually draw you for whatever reason. You're drawn to them, and you need to know as much information about them as possible because of this kind of attraction that you have.
Is this the Ramses head? Sorry, Chris. Is this the Ramses head from the Revelation of the Pyramids documentary? Is this
Yeah.
This is okay. So maybe just explain the reverse transparency technique for those who haven't seen that. But I'm sure when listening to the show, they probably will want to see it. But
yeah,
because this is the one that really grabs me. And if anybody doesn't understand metrology or precision measurement, I mean, the reverse transparency technique just sings praises for what these guys did. Like, you can see the mirror imaging of and the perfection in just a transparency photograph.
Yes, and that technique is, it's very simple. But at least for the operator of the computer, you take the photograph, and my software has a function where you can make it like a 50% transparency. So you make it see-through in effect.
Sure.
You can still see the features of it, but you can look through it to any photograph or object that is behind it. and then taking that photograph and reversing it along the horizontal plane, so you're just flipping it around, and then overlaying it onto the original photograph, and then comparing both sides of the features of the head, the right to the left.
And then we see that whole bilateral symmetry in the face. The left eye matches up with the right eye, the cheek with the cheek, the width.
Yeah, there is a it's quite surprising when it's done. The 2008 Revelations of the Pyramids documentary, when they interviewed me, I didn't have the perfect example that I was able to gain later in the year, because I went back in November of 2008, and I was able to take a photograph that was closer to the central axis of the head.
Yeah, yeah.
But even that photograph, it's like you could, and to explain to the listeners that, when you have a three-dimensional object and it has been manufactured or machined for you, the designers actually created in Cartesian coordinates. You have your X, Y, Z, these three planes, from which the dimensions or the geometry is built on those X, Y, Z planes. So when you look at the Ramses head, you see a photograph, you're looking at the XY plane.
Sure, it's two-dimension photograph, but it's
right.
In reality, the whole thing is a three-dimension.
But in reality, you have the Z plane, which is moving, away from you and passing through the object. That is, that is not discernible when you take a two-dimensional photograph. And so my first photograph that I took, the head or the camera orientation was shifted a little bit, so the Z plane was a little off axis with my camera. And what happens when that happens, you have features on the object that are closer to you and features that are further away on the Z plane. And it causes a shift. If you flip it, you may be able to match up features of the nose, but the jawline will be thrown off a little bit, simply because the angle of orientation is off a little bit. And so my first photographs had that kind of shift, but still, it was understanding the problem. That if I was able to take a photograph that was exactly along the Z plane, I would capture the X, Y, and Z in the same orientation as the object was designed and built. So
it's significant for the accuracy, isn't it, Chris? This is highly significant because you get the perfect accuracy of what you're trying to do, then what you're trying to achieve.
Well, when you consider what we know about that ancient culture and what we know about ancient Egypt and what we've been taught, just the fact that you are asking those questions is significant enough.
Sure.
Because you've already captured enough information to explore that third axis further. To determine the reality of the piece, how precise is it? We're talking about three-dimensional geometry, surfaces that we create today in manufacturing to manufacture several products, many products, in fact. A computer mouse or a car or a television, cell phones, all of these have three-dimensional geometry that are created in computers, and that information drives machine tools that create the dies to manufacture them. And so finding similar situation or a similar kind of body of knowledge um, that reaches forward from thousands of years ago, and it says, look at this. This is what we were doing thousands of years ago,
Mm-hmm.
and now you're catching up with us.
And it's funny, you just mentioned at the start of the show there, Chris, where technology was only developing, as you were saying, in 2004, just to measure this stuff with computerized software and techniques. Like, that's just to measure it, to be able to accurately say this is happening.
Yeah, and you know, digital photography and manufacturing's been out for quite a bit. The manufacturing company that I was working in was beginning to introduce it and be interested in it. It was becoming a little more prevalent in manufacturing, and so while it may have existed in some of the larger companies and labs, you know, it takes a while for that technology to spread and be accepted. And so in 2004 was pretty much where you know I kind of said, well, you know, here it is. When I was going to Egypt in 1986 and using a 35 millimeter film camera, I had never realized that instead of a square, a straight edge, and calipers or whatever else I was using, I never realized that a lot of the metrology instruments that we use today for measuring pieces, like numerical controlled computer coordinate machines, and so it's like
optical lasers and
all that stuff. It never occurred to me that I would have in my hands something that I could at least achieve a percentage of what was being done without any physical instruments, without having to worry the guards or get permission to physically measure an object, because I was just another regular tourist,
sure,
with a camera, and so it was quite an amazing period of time when I was doing that research, and the results obviously are fairly significant. There are imperfections on those statues, and also on the headdresses.
I think that's something you point out, Chris, in the Lost Technologies in Egypt. You do point out when there is imperfections, and you do make note of that. You don't make these guys out to be, you know, super engineers. Like, yes, they were very advanced, but there was sometimes imperfections, and you've spotted some errors in the tool marks, and you would expect to see that too, Chris, wouldn't you? You would expect to see some sort of a manufacturing process where it may have gone wrong, but covered up and smoothed out, and etc.
Yeah, actually the Ramses statue in the British Museum is a prime example, because what you see there is you have the same geometry, you have the same symmetry, bilateral symmetry, the perfection of the face, but look over here, there's a slip of the tool, and that's in the corner of the mouth. So if you go into the British Museum, go look at the Ramses statue and pay close attention to the mouth, and it's on the left side of the face. The right side when you're looking at it, but the left side of Ramses' face.
I'm going to be there in 2 weeks, Chris. I'm going to be
So
I'm going to be doing exactly that.
Yeah, a slip of the tool. And it's like the tool was driven deeper at that point into the mouth, leaving a cavity that, you know, it makes old Ramses look like he's snarling rather than smiling, but they had attempted to improve the appearance by cutting the lips deeper. And so by cutting the lips deeper, they removed, you know, a portion of that mistake. It was probably more pronounced when they noticed it. And why it happened, I don't know, but you can imagine that if you have an automated machine crafting a particular feature and the material shifts, then you're going to have that problem, or maybe the tool actually comes loose, or there's all kinds of mistakes that can happen when you're involved in that process. It's just a fact of life.
Sure.
And so when I found that, it's like confirmation to me. It's just like, oh wow, it looks like it's machine, but wait a minute. Yeah, the damn thing was machine, because look at this.
Yeah.
A sculptor would not create that.
Yeah. You wouldn't.
And when you look at the cusp of the lips, where they cut the lips deeper, they sunk them deeper into the face, very pronouncedly. You have this very sharp cusp where the lips meet the vermilion border, and the philtrum. There is a kind of a triangular cusp there.
Sure.
That is very sharp. And so understanding how sculptures work and understanding how machining is done, you can take the sculptor, the handwork off the table, clearly.
Yeah.
They don't leave those kinds of mistakes.
Yeah. Dave, sorry, Chris. Dave, do you want to jump in there at some point for a question, or?
Well, just really to ask you, Chris, about the this method of creating the statue of Ramesses, very much based on symmetry, very much based on geometry. Have you come to any conclusions as to why the ancient Egyptians would work in this way to produce some kind of likeness of Ramesses? Did those aspects of it cross your mind when you were discovering all this?
Yes, of course. And the why, the how, the when is always a prominent question. One of the things that I did notice, and because I didn't have an authorized photograph, I didn't use it in my book, and I didn't really enter into the discussion of are the Ramses statues actually images of Ramses the Great, Ramses II. And if you compare the geometry, the facial geometry of the Ramses mummy, a profile of the Ramses mummy. So you have the relative positions of the nose, the ears, and the mouth. Mm-hmm. And you overlay that with the Ramses statue, the information that you have on the Ramses statue, they don't match. They're not even close. And of course, the question is out there and has been proposed by other people, were these artifacts adopted? And we know that cultures will personalize objects from previous civilizations or previous generations, particularly in that area where they try to remove or obliterate symbols or images that reflect a different belief system.
Yeah.
And so
Akhenaten being one of the most famous, I think.
Exactly.
Yeah. And so we know that was happening. And then of course, when we consider the presumed technology that was necessary to create these artifacts, I have to ask the question, does this actually strip the artifact away from Ramses or the time of Ramses and push the time period further back?
Wow.
And there are lots of indications that was actually happening. And you'll find also in the Luxor Temple and in other facilities, areas, the Serapeum near Saqqara is one of them, where you'll find the crude scratches of later cultures that are personalizing these objects, and they are nothing like the ancient tool marks. They don't have the quality. They don't have the precision. The surface finishes. They're just nothing like it. They're just crude scratches. And
you mentioned about in the book about Amenhotep, and there's something like 250 plus statues of him, and it kind of beckons the idea of a production line of these guys mass producing statues in a way.
Well, isn't it funny that engineers would think like that, James? Because that's exactly what I thought. It's almost like, they had this model.
Replicate it.
Replicated it.
Get it to work once, make sure it's right, and then just reproduce it.
Right. Why not?
Why not? Yeah. I mean, if the empire was so big and you want to dominate the empire and you want your picture everywhere, I mean, mass production is the way, is it not? So.
Yeah, and I'm not sure that it was that they wanted to represent any particular person or even to dominate their empire. It is a common theme though through history where great leaders will have images of themselves created, or they will create great works that memorializes them. And then, the greater the work, the more intimidated their enemies will be. And but to me, the Ramses statue, it doesn't have that kind of feel to it. If you look at the geometry and the representation that it invokes, you can see, certain harmony with it. I mean, I bring that out in my book too, because, and then in a presentation that I did on the Nile on the Egypt trip, when I introduced the photograph that showed the flower of life.
Oh, yeah.
Superimposed on the Ramses face, and you see the correspondences between the features of the face, such as the eyes, the lips, the nose, and the pineal gland, the location of the pineal gland in the center of the forehead. You'll see that the flower of life seems to incorporate all of that, yeah.
And something you also going to do is you use Fibonacci spirals, Pythagorean geometry, and the golden ratio to show the illustrious artistic mix of technology and art. It's this wonderful woven mix they have. It's like art and technology. You can't tell where one stops and the other one finishes.
Yes, that's and that is kind of like for me that's a philosophical question. When you're looking at a blending of art, harmony, technology, and what part of that do you actually resonate with? And I find myself resonating with all of it more than I used to, because when I first started my research, I was looking at it with my left brain, but when you start to ask those philosophical questions about, what is the most important feature on this object, and it kind of brought me to the realization that the most important story behind it is the inspiration behind it, and that's the most important story in our civilization is the spirit, the inspiration.
Why carve something so complex, so difficult, so ingenious, because you have the skill to do it, perhaps.
Yes, and there is a school of thought and that the ancient Egyptians were not, or the Cometians, which is what Stephen Mailer proposes,
Sure.
and which I actually believe strongly that there was a civilization prior to the ancient Egyptians,
Mm-hmm.
and they lived in a state of harmony, and the right and left brain were functioning
Together.
together, and so I know, they were transferring information much as our geniuses and inventors do in accessing information that has not been revealed about nature, about the universe, and then transferring that information to the left brain and processing it in a three-dimensional world,
Mm-hmm.
and showing what that genius can create. That's how our civilization has developed.
Mm-hmm.
But the school of thought, looking back, shows that they were working on both sides of the brain. So whereas you may take an individual and say, okay, I'm going to create a statue of somebody who looks like Tutankhamun, and even that, you look at the human body. I mean, that's divinely inspired, obviously. But but to say I'm going to create a statue that represents universal harmony and it's going to incorporate sacred geometry, and I'm going to create it in such a way that it conveys that information on a very subtle level that people will actually tune into and be affected by, then Egypt is a perfect example of that. Not just, the statues, but also the temples and the pyramids. It's just a perfect example of that kind of that kind of condition that existed in the minds of the geniuses that were involved in it.
Mm-hmm. Do you want to jump in there for a question, Dave?
Well, yeah, I mean, just to really share some ideas and get Chris's take on it, really, because I can't help thinking when I see, the symmetry and the geometry in all of this and the way it's perceived, that somehow the ancient peoples had a different perception of this. Maybe it was more through the right brain than the left brain, as you say, because I think our society is very much left brain dominated. But I wonder if, in a sense as well, there's something about making a statement, if you like, in this ancient geometric art and so on, that is about saying that all proceeds from order, all proceeds from geometry, all proceeds from number, rather in the way that Plato spoke of, the ideal world. And I just wondered what you thought about that sort of notion, Chris.
Well, I agree with it. Obviously the thought behind the creation of ancient Egypt was rooted in this divine inspiration and wonder, and exploration of nature around us, because all we have to do is look into nature to access that information, and so the right brain, I have come to the conclusion, is actually it's more important to us than the left brain. The left brain is kind of a functionary part of our being, I think. And it's pretty much the only way that we can express in a three-dimensional world, or actually convince in a three-dimensional world, because you can have your right brain working, and you can be inspired with great thoughts, and then of course if you are articulate and convincing, you can have people try to understand what information you're gathering, through your right brain, through your words and writing, art, and sculpture. But the sculpting, of course, you have that practical, the practical side of you, where yes, you need tools, you need to know how to use those tools. But the sculptor, if he is, true to his craft, he is definitely tuned into his right brain and understanding the materials, how to work with the materials and what kind of shapes or images he wants to create. And I suppose, in a way, when some people may be a little turned off if you say, oh no, well, the Ramses statues were machined, because that kind of puts it in a cold, hard, smokestack factory environment where
takes the mystic out of it.
Yeah, it takes the glamour out of it, the kind of spiritual aspect of it. But that's where we make a mistake, because we have this kind of dichotomy, where we have said, oh, okay, spirit good, material bad. When really, in reality, everything is spirit. Even within the material world, how can you distinguish between what is spiritual and what is not spiritual, when the driving force in everything that we do is spiritual?
Would you like to have worked with the engineers back then, Chris?
I sure would. Yeah, I think that would have been a real joy. To go back in time and actually, even if as an observer and looking over their shoulder, or going around with a brush and an ash pan and
jotting down the trade secrets
and sweeping up their shavings, I think that would have been cool.
Okay, so sorry, just want to jump in there. On that note, these guys, let's say they are machining, okay? Let's say I tell you now, Chris, there's your CNC machine in the modern age. Do me a statue of Ramses, the best one that's out there. Pick one that's the best one, the most 3D perfect one. And I say, do it out of the hardest material, the hardest granite you can get. How difficult is that to do, Chris? Even with all the modern machinery, it's obviously can be done, yeah? How perfect is it going to come out? Is there going to be any errors? Is it going to have to be done 2 or 3 times? Can mistakes happen? Is the finish going to come out perfect? Talk us through that process, what we would have to do in the modern age.
Well, today we have machine tools, obviously, and also we have computer software that could model a Ramses head or face or the whole body quite easily. Well, I'd say quite easily. I mean, obviously there'd be quite a bit of work to do, but it's definitely within our reach to do that. That is a discipline and a skill in itself. But then you'd have to involve the quarry workers who would deliver the material. So you have to look at the industry that supports that and the infrastructure, and also the tools that they use for quarrying. So the whole process and all the ancillary requirements to the final cutting of the face, where the beauty is finally revealed. There's a lot involved, and today, of course, we know how to quarry. We know how to haul materials. Of course, some of the Ramses statues are quite heavy. You're talking a few hundred tons. So, the material would be expensive. And then the designers would probably not be the people who are tending the machines. You would have different people doing that.
Different crew, yeah.
Yeah. And, in industry, a lot of times it is well, most of the time, it's wise not to mix crafts, because say you have a production worker or a machinist or, a machine operator who's making production parts.
Mm-hmm.
He is, his training is to, is on production. And so
Acquire skills in that one zone.
yeah, he acquires certain skills, and those skills are to make parts the most efficiently within the requirements. But you won't want to take production parts and put them in a gauge shop or a tool shop, mm-hmm. where you have gauge makers and tool makers who have been trained to actually be a lot more careful in how they measure and how they cut. Because the efficiencies would go down. So, they would, the requirements on a tool maker are not the same as the requirements on a machinist. Mm-hmm. And so, that you have these different classes of trades where you may have a certain class who will be roughing out the statue, mm-hmm. Taking the bulk of the material away from it, and then perhaps they would pass it on to the final
finishing
machinist using a different set of tools. And
do you have any? But my point then is, Chris, knowing what's all involved and all that, and the immense effort even in today's standards, what do you think the machines could? Do you have any idea what the machines could have been? Obviously, that's a big question. If there was machine tooling, I'm thinking maybe something like the Roman contraptions of these wooden catapults that they made. Could it be made out of wood? Does it need to be metallurgy involved? Maybe the actual tool bits were metal, but perhaps they had like wooden contraptions with arms and sliding rails and stuff. Perhaps that, Chris?
I've kind of discounted that. The use of wood in controlling as a mechanical a piece of a machine, or mm-hmm. Mechanical member of a machine. Wood does not have the precision, or could not produce the same kind of precision that we find.
Expands with the heat and cold and the density and.
Right, exactly, and so I kind of discount that because of the
tolerances.
The tolerances, yeah, because you go to other areas of Egypt and you say, okay, so we haven't really quantified the precision of these Ramses statue. How can we say that the ancient Egyptians knew the tolerances that we work with? Mm-hmm. Well, all you have to do is go to into the Serapeum, Saqqara, and go through the rock tunnels there and examine the boxes that you'll find in the Serapeum.
I'm glad you brought that up, Chris. Let's talk how that's probably one of the most precise things you've measured in Egypt, isn't it?
Yes, I mean, it's like the smoking gun for me in terms of the level of technology that they had achieved, because it reflects the development of their understanding of manufacturing, and not just that these things exist, but they were no accident. They were perfectly in command of an understanding of geometry. They were in command of an understanding of precision down to a fraction of an inch. Not only, over a small period or a short distance, but over a long distance. So the boxes in the Serapeum, I first went there in 1995, and I was quite shocked to find I had a straight edge with me, and I was quite shocked to find that the surface of the boxes seemed to me to be as in the same condition or as precise as what I know in a tool shop or an inspection lab with a granite surface plate. And those objects are finished to within about 2/10,000ths of an inch. And here I have a straight edge with an extremely flat surface that was finished to within 2/10,000ths of an inch. And I'm sliding it along this piece of granite in Egypt that was created thousands of years ago, and I'm finding the same condition.
Wow.
And then I was back again in 2001, and I was able to go down there. I had a very precise toolmaker's square with a 14-inch blade, because I wanted to find out just how square, what was the geometry, how square the inside of these boxes were. And I was amazed to find, I put the blade on the surface of the inside wall and the base on the underside of the lid. And I was amazed to find that it was perfectly square.
Too, as well. I can't see Egyptology in the same light again. It's things change when you read your books, Chris. This is not a paradigm shift. This is a paradigm buster, this stuff.
Well, thank you. Egypt certainly changed for me after I paid it a visit. I mean, even before, when I was reading about all the information that is not generally available to people when they're in school, my mind was changed then, but actually visiting Egypt opens your mind quite a bit, particularly for an engineer.
Sure. Yeah, and I guess that's the thing. A lot of engineers flock there, and the engineers have a different eye, Chris, and I guess that's what we talked about last time, and this is the difference that you bring to the table. Obviously, you'd work in a different engineering. You work in the precision engineering field, and you understand precision. You've got the eye for it. You understand tool making and tooling, and this is what the Egyptians did. Like, I mean, they engineered very difficult. I mean, Shock will have his followers of geology, and like you, Chris, you know, anybody that's into science and engineering can clearly see the problem that these Egyptologists are facing with copper chisels, highly machined granites and diorites, extremely hard stones. And I think what you've brought to the table is you've brought this methodology for people that have any even technological know-how to go, well, we don't have the engineering eye, but Chris does, and he's able to present it in his books and in this manner and show us the problems, show us that there must be tooling, there must be machines, something had to guide these chisels or whatever they carved this stuff with, like.
Well, yes, obviously the facts are there, they're on the ground, and all you have to do is go and look at it and measure it. Mm-hmm. And of course we can discuss about what kind of tools were used. Mm-hmm. But in those discussions among engineers,
the time.
Yeah, man without a country, I think. But no, I've been actually honored and humbled to be able to explore and discover and bring this information to light. And it's very gratifying to meet fellow engineers all over the world that appreciate that and are adding their own voice to it. So it's incredibly satisfying to me.
I guess in a way it kind of reminds me of when Shock has the geologists on his side, because geology follows the science, and Egyptology doesn't have qualifications or any right to discuss really in-depth scientific geology or engineering. They're not qualified engineers. They're not qualified geologists. And these are the two battles that they're fighting, I guess, Chris, is what I'm trying to say. But like, So, the last time we talked to Chris Dunn, we discussed the Giza power plant theory and his book, The Giza Power Plant. Today, we're going to be discussing lost technologies of ancient Egypt, advanced engineering in the Temple of the Pharaohs, and he's going to give us an update on his recent trip there. So, let's not delay our guest anymore. Welcome to Capricorn Radio, Chris.
Thank you, James.
Sure. Now, man, what a beautiful book that is. Like, I'm an engineer, Chris. I appreciate this stuff. Like, but I guess, the thing for me is I don't see, with the Giza power plant, old complex designs. And I guess this was like a playfield for you when you went there and you turned it into research then. Would that be fair to say?
Oh, that is a very, very good description of it. And, just to kind of bridge the gap between now and when I started my career and how precision plays into it. Mm-hmm. I began an apprenticeship at a very young age in Manchester.
Sure.
Down the road from David, just a stone throw away, right, David?
Yes, absolutely, yeah.
And of course, Mancunians and Liverpudlians always hold a tremendous respect for each other.
I like your humor, Chris.
And talking to you guys, my accent is probably going to drift back into my Mancunian accent. I don't know.
But I'm always intrigued by your accent, Chris, because it sort of drifts between the two all